we'll see the young researchers who is going to pitch through their 1-minute pitch on what they have been doing, how our Center for Future Materials has been researching and developing on materials for the future, or how the materials are to be used in future. So let's welcome our presenters. Let's give a big round of applause. Thank you.
Hello, I am Minol Udagedara, and it is very important to know the structural health of a civil infrastructure to avoid any catastrophic failures. In my research, I am developing a framework for structural health monitoring of civil infrastructures by using fiber optic sensor technology and using deep learning, which is an subcategory of artificial intelligence. To train my deep learning model, I use finite element analysis based data. And to test my deep learning model, I use the data from real world concrete structures, which is gathered by or acquired by fiber optic sensors. My model is expected to be more accurate and robust when compared to other methods, and increasing the safety, and finally increasing the safety and well-being of the people as the outcome. Thank you.
Hi, I'm Sandaruwan. As we all know, people are going back to the moon again. And this time we are going to stay. And in order to stay, we have to have good habitats on the lunar surface. And that's where my shape memory polymer composite comes in. My SMPC is durable, deployable, lightweight, and it is cost effective. And the main research hypothesis behind my project is to fabricate the structural components using this shape memory polymer composite on Earth and fold them to take less space in the payload fairings of the rockets, send them to the moon, and then deploy or recover them over there and construct the habitats on the lunar surface. And for this, right now, we are developing a shape memory polymer composite incorporating cyanide esters and epoxy-based shape memory polymer composites. Thank you.
Hey everyone, my name is Yubai Zhang. My research is mainly focused on design fire-safe materials for lithium-ion alkali-ion batteries. As you know, lithium-ion batteries have been widely used in our daily life, from mobile phones to electric vehicles. However, the fire risks surrounding this technology is causing huge injuries, casualties, as well as economic losses. In my research, I will try to enhance the fire safety of alkali-ion batteries by improving the fire retardancy of electrodes using the functionalized grain cellulose binder, and enhance the thermal conductivity of battery components, including electrodes and electrolytes, by using the functionalized 2D materials. At last, we will realize a fire-safe and reliable alkali-ion batteries for its wide applications in energy storage area. Thank you.
Hi everyone, my name is Guoliang Chen. My research is focused on high-temperature proton-conductive composite membranes. As we know, the fuel cell can directly produce electricity with an electrochemical reaction. Hydrogen reacts with oxygen and produce water. And the proton change membranes, which only allow the transfer of protons, in the heart of fuel cell. And the conventional nothing membranes couldn't operate at high temperature. And in order to achieve high proton conductivity, 0.1 Siemens per centimeter at 120 degrees, we directly incorporate proton conductive crystals in PBI membranes. For synthesis kind of material, we choose mechanical synthesis method compared to hydrothermal and layer-by-layer method, which use a large quantity of toxic solvents. We directly put two chemicals in a bone meal jar at a very high speed, and the reaction only can complete in a short time, like 5 minutes. So it's really fast and green synthesizing method. Thank you.
Imagine not being able to go for a walk simply due to a chronic wound that gets worse and worse over time. The incidence of major amputations due to chronic wounds is 4 times higher in First Nations peoples living in rural and remote regions. Hi, I'm Dinuki, and my project incorporates traditional bush remedies and waste product extracts into hydrogel dressings to treat chronic wounds in rural and remote regions. Currently available and newly developed wound dressings are either too technical, too expensive, or require facilities that people in remote regional communities do not have. So I'll be using these components to make the hydrogels to treat chronic wounds, where the plum peel will be used to indicate and sense the pH within the wound environment. As the alginate concentration increases, the flexibility of the hydrogel dressing also increases. Then I'll be using calcium chloride to actually cross-link the hydrogels, where my project will be basically building up a hydrogel that is sustainable, cost-effective, and potentially biodegradable. Thank you.
Hi, I'm Janitha. Plaster of Paris and fiberglass materials are more popular in orthopedic, which used to protect and immobilize fractured bones until they get healed. However, these materials have many disadvantages as well. Therefore, I synthesized bisphenol A-based shape memory polymer smart material named Ortho Plus. Ortho Plus is less weight, has less setting time, easy to apply. The process is much cleaner and quicker. In number 2, I demonstrated lower limb leg cylindrical cast using Ortho Plus in less than 10 minutes. Ortho Plus offers some unique features as well. During the process, there is no any chemical reaction. Orthopedic technician can form this material into any complex shape, and it's possible to control undercast pressure. Most importantly, Ortho Plus can reuse after disinfection. Therefore, I believe Ortho Plus will be a good candidate for next generation orthopedic material. Thank you very much.
I'm Jayani Anurangi. My research topic is structural energy storage composite. Here, my objective is to incorporate energy storage capability to the structural composite. So this kind of energy storage composite are suitable for many engineering applications, such as we can replace the body panels of vehicles by using this energy storage composite, as well as we can replace the bricks of the buildings using this energy storage composite. So in my research, main focus was structural energy supercapacitor functional structural composite, because it has laminated structure. When I developed the electrode, I used the graphene coated carbon fiber layers. So after fabricating the structural supercapacitor, I evaluate the electrochemical properties. So according to my results, I calculated that around 2 watt-hours per square meter energy I can store in my composite. Thank you.
Everyone, my name is Jiabing, and today I'm going to show you how green chemistry contributes to fire-retardant PLA. My research objective is to develop a solvent-free synthetic approach for polyphosphoramide and halloysite nanohybrids for creating fire-resistant PLA with improved thermal stability. And this is the illustration of methodology. And we don't use any solvents, but successfully synthesized this polyphosphoramide-based flame retardant. And then it shows excellent flame retardancy in PLA. And finally, we achieved the green synthesis of polyphosphoramide flame retardants without use of any solvents. And then we obtain thermally stable and fire-resistant PLA. Thank you.
Morning, ladies and gentlemen. My name is Dr. Leila Javazmi, and my research focusing on developing a new prototype composite using graphene nanofiber sensor for smart health monitoring of infrastructure. Flexible graphene nanofiber were fabricated using a customized electrospinning setup, and results shows this graphene nanofiber sensor exhibit excellent sensitivity and stability due to its continuity and higher conductivity as well as brightness. Also, the project is a promising method to create a multifunctional innovative structure with ability to carry electrical current to measure impact loading in infrastructure. Thank you so much.
Hello, my name is Molly, and I'm researching dielectric Cure monitoring methods for thermoset composites. For this, I am working on a precise and accurate method of correlating the dielectric parameters to the polymerization reaction of an epoxy carbon fiber composite that's about 2 centimeters thick. This addresses two of the main challenges we have within aerospace process monitoring, which are we're either monitoring indirectly, so looking at temperature, which doesn't necessarily relate to material property development, or we're only monitoring at one specific plane of measurement and we're neglecting what's going on through the thickness of the part. The outcomes of this research are validating this through thickness dielectric sensor and identifying the limitations and capabilities of dielectric analysis, with the ultimate goal of developing a new direct monitoring technique which could be used for certification and quality acceptance of aerospace structure. Thank you.
Hi, everyone. My name is Song Ming. My research is about experimental and numerical study on defects of part-treated composites. These defects in this research include fiber misalignment and non-uniform fiber distribution. These defects are very common, especially for thick composites, which will affect the mechanical performance. A new method is developed to correct these defects. The benefit is that it can give us a quick estimate on mechanical performance and give us an exact input to FEI model to help us establish the relationship between these factors and the defects. Then these factors can be optimized during the early design stage to produce defect-free products. Okay, that's all. Thank you.
Hello, Choman is here. As you heard today from Tom from Australia, one of the main areas of developing a railway sleeper is testing. Therefore, I'm presenting a novel bending test method for railway sleepers. And the objective is basically to develop a testing method that predicts the behavior of or in situ behavior of polymer sleepers. As you can see from figure 1, a railway sleeper and the positive and negative bending moment, which creates this W shape. However, the current testing standard doesn't consider this bending shape and requires many tests to achieve that. Therefore, I'm presenting 5-point bending test where you can see a W shape is obtained. And the second photo shows the actual photo of the test where you see a timber sleeper failed with a DIC strain mapping and the failure mode shown in the bottom. So the outcome of my research is that this testing method is useful to all sleeper types and materials. Therefore, it saves time, effort, and money. At the same time, we can apply realistic bending moments as well as shear force. Thank you so much.
Hello, everyone. This is Hadi, PhD student in geotechnical engineer at CFM. Reinforcing elements such as rock bolts and cable bolts are common techniques to improve the stability of underground spaces such as underground mines and urban tunnels. These elements are usually anchored using unsaturated polyester resin, and the behavior of these systems may be affected in higher temperature. This is very important due to the safety of these environment in the presence of fire or combustion. In this research, we conducted a comprehensive experimental study to evaluate the behavior of this system in higher temperature. By conducting several plot tests, it was concluded that the axial behavior of these elements decreases significantly when the temperature of the environment reaches to around 50 to 65 degrees. Thank you.
Hi everyone, this is Shima, and the main topic of my research is the axial load transfer mechanism of rock bolts. I'm conducting some skull and bolts large scale tests using the pull-out tests, and I'm about to investigate the effect of adding fly ash to the grout and find out what happens to the strength of the grout. So using this mining-based material can reduce the impacts on the environment. Thank you.
Hello, I'm Shanika, and I'm involved in a natural gas pipeline repair project in US. Critical natural gas service in US through a network of 3.2 million kilometers of utility pipes are over 60 years old. Pipe-in-pipe or PIP system is an emerging technology to repair of circumferentially cracked pipes or piping joints. However, the experimental evaluation on the performance of different PIP systems in repairing full-scale pipe is very costly and time-consuming. Therefore, this study aimed to develop a simplified analytical model that can reliably predict the behavior of PIP systems subjected to lateral loading. The theoretical model of 4-point bending test was modeled using fiber model analysis, considering the nonlinear material behavior, and validated using finite element and experimental results. The research revealed that fiber model analysis is able to provide a better understanding of the flexural behavior of PIP system in considerably short time period and agreed well with their FEA outcomes. Thank you.
Hello everyone, this is Three Things. I'm researching on the edge effect of the hose pipe on the PIP under internal pressure. And after a long time in service, the hose pipe can be corroded and doesn't have the full strength. So the PIP will bear the full load and has the high stress concentration at the broken edge of the hose pipe. We use the finite elements to simulate different scenarios with different materials and loading conditions, the crack edge as well. The two significant findings are the stress concentration can get up to 30% high and can undermine the design life. And the high strength material property proven to be effective in the stress concentration relief. Thank you very much for your attention.
Hello, everyone. My name is Hamid. Mr. Ahmed Salah was not feeling well today, so I'm presenting on his behalf. The topic he's working on is the development of analytical and numerical models to evaluate the impact of axial thermal stresses on the performance of pipe-in-pipe repair systems used for the rehabilitation of gas pipelines. This project is sponsored by the United States Department of Energy, and the developed analytical and numerical models can assist the designers and the developers in providing safe and efficient PIP repair systems that the pipeline industry urgently needs. They can also replace the expensive and time-consuming experimental procedures. Thank you.
Hi everyone, my name is Long Nguyen. Our project aims to develop a smart serial poly field detection utilizing CCTV inspection data and AI deep learning. Our methods sought involve to the annotation field in CCTV inspection data, and is what part of several state of deep learning network for training. Our contribution include the adaptation and reconfiguration several neural network for detect multiple cracks at one in real time to stimulate real-life condition and diversify the network. We have applied augmentation technique to the data set to improve the network robustness. We have completed several tasks to optimize our AI model and tune the key hyperparameter. As a result, the average precision was increased by 1.7 times, while the training time was increased by 10 times, and it has successfully detected multiple cracks using CCTV inspection footage. And this one had potentially to replace human for data reviewing and making the decision. Thank you for listening.
Hello, everyone. My name is Behshad, and I'm working on sensitivity analysis of fully-graded pull-out tests for right-bolt systems. For this, I'm planning to conduct several pull-out tests, with considering changing some influential parameters such as type of grouts, size of confinements, and water-to-grout ratios. The tests will be conducted in 4 different weeks, and my outcome would be building a data set for a small and large scale pull-out test, and also predicting peak load and displacement with utilizing AI methods and suggesting new relationships. Thank you.
Hello, everyone. It's me again, Hamid. Recently, I have applied for a capacity building grant, and if successful based on this grant, I will focus on the analysis of fiber composites for a sustainable and climate resilient navigational aid structure. Currently in Queensland, these structures are made of steel, which has a huge corrosion problem in an aggressive marine environment. costing Queensland government over $4 million per year for the maintenance of these infrastructures. Replacement of steel with FRP composites will eliminate the expensive maintenance activities. But before doing that, we need to evaluate the performance of an FRP composite navigational aid structure subjected to sea waves, currents, wind, and small vessel impacts. That is the main objective of the proposed research project, which can be extended in near future to a partnership with Wagner's and Queensland Department of Transport and Main Roads for future grant applications. Thanks again.
Hello, my name is Xianyang. I work on torsion in GFRP reinforced concrete pontoon decks. Pontoon is always suffering from torsion because of wave actions. The inclined torsional crack will initiate from the corner of the edge cutout, which is a compulsory design for pile fixture purpose. Eventually, the steel reinforcement inside will result in corrosion. GFRP reinforcement can permanently eliminate the corrosion issue in this case. However, the torsional behavior of GFRP reinforced concrete deck have not been addressed in any Australian or international design criteria. An experimental study was conducted in my research. The generated torque twist curve in the right side shows the negative effect of the edge cutout on the torsional behavior. But 2 layers GFRP mesh reinforcement distribution can enhance them. Additionally, an equation was proposed to estimate the post-cracking torsional behavior by considering the contribution of the bar distribution. Thank you.
Good morning, I'm Adrian Rex. Now, concrete is a ternary mixture of aggregate, cementitious materials, and water. The aggregate properties, chemical, physical, and mechanical properties, all have a significant impact on the performance of concrete. And all these properties also vary, both between quarries, within a quarry, and even within a batch. Probably the most important properties of aggregate is how the aggregate particles pack together. And this packing of particles is dependent upon the shape, size distribution, and size. And these are difficult, if not impossible, to control, and certainly very difficult to reproduce. The aim of this project is then to develop a model aggregate to assist in improving the reproducibility of testing and research into concrete, a model aggregate whose properties, and in particular size and shape, are reproducible. Thank you.
Everyone, my name is Jess. I'm developing a circular economy model to help redesign supply ecosystems to prevent material waste. To achieve this, I need to take into account several factors, including what changes are needed to collection and processing infrastructure. How does transport and energy costs influence placement of that infrastructure? Is there potential to reduce costs of handling and disposal and create profit? And lastly, any change has to be acceptable to users of that system. All of these elements are input into the model, and this allows us to explore economic, environmental, and social sustainability of any supply system change. The model will then determine the best material pathways to allow and facilitate commercial opportunities and inform policy change. As an example, if traditional pathways for waste are insufficient, what changes do need to be made to allow new applications, and are they viable? I'll pass on to Matt now to give an example of that. Thank you.
Everyone, my name is Matt, and I'm working on developing a circular economy for plastics. Now, when most people develop a recycling process, they target single stream wastes, which is high purity materials, but they're also generally expensive. This leads to mixed material waste, which are low cost materials, mostly being sent to landfill. We're working on developing simple value add applications for these materials to divert them from landfill. As an example, we made this polyethylene paperboard composite from disposable cups. All we do is take them, put them in a hydraulic press and apply heat. And we get this material which has mechanical properties approaching those of MDF with a significantly lower energy input, as seen by the large difference in embodied energy. There's an example of this mounted on the wall over to your left. And this is just one of our examples of a method to use over 1 billion disposable coffee cups generated in Australia every year and divert them from landfill. Thank you.
G'day, my name's Dr. Tristan Shelley. I'm presenting on behalf of David Twine on this slide. So David's research is looking at artificial intelligence ways for in-process detection of defects in aerospace components. He's beginning with manufacturing step, then using a pressure mat system for identifying abnormalities in the layups. And then he is developing AI methodologies to identify the defects and also identify areas without defects. This technology that he's developed is currently at about 64% accuracy, but he'll be able to push that through using algorithms from Google and Microsoft to over 99% accuracy. This technology will also help in terms of reducing scrap parts and lead to higher profitability in manufacturing processes. Changing gear a little bit, the Institute for Advanced Engineering and Space Sciences, within which CFM is a part, has recently been awarded the iLaunch Hub, which is a large pot of money from the Australian government for accelerating the national manufacturing priorities, of which space is one of those. Currently, the space launch market is less mature than other areas, other countries, around the world. And this project is looking to kickstart the space launch and space vehicle manufacturing sector in support of the already mature payload industry that exists within Australia. We've got 3 key streams: commercialization projects, the iLaunch Accelerator for commercialization and also short-term projects, and a big push on primary to industry education. Thank you.
Hi everyone, I'm Polly Berry. I'm one of the theme leads within the centre. I'd like to again thank all our speakers. I'm going to get them to come on the stage and we're going to get a nice photo of everyone. So these guys have been practicing really hard the last 3 weeks to make sure that all went smoothly. And as you can see, that's a bit of a taste of all the research that we carry out across the centre as well. So if we could just give them one last round of applause for all of them. A long one, yes, because there's 26 talks, I believe. And that was a really quick run through. A lot of these researchers also have posters present in the poster session. So if it was a little bit too fast, you can actually go check them out during the poster session later in the day as well. One thing I will mention, the next thing is actually lunch. I will mention for the professional practice students, so those who are enrolled in the Master of Engineering Science, for your lunch break, you are over in Ellison Dixon. So when we break, you guys want to head over there to get your lunch. And then you can also head to the refectory to also check out the poster session during that time as well. And then after lunch, just as a quick note, we do have the lab tours. Shui Sen, are we meeting here again before we go there?
So for the lab tour, we're gonna collect our lunchbox from here, and then we move to the building. It's on the right corner there. It's called the R block. We have lunch there, and also we have poster display, and the 2 companies have the exhibition there, BAC and Sunlight. They have some display there, so go and have a look. We have a shuttle bus just outside our block, but we will have our students and researchers to guide you where to get the shuttle bus to our lab. Can you check the time?
Yeah, so we've got the lab tours scheduled to start at 1 o'clock.
Yeah, 1 o'clock. So we have time for lunch and have a look at the posters in our block now. The lunch and the drinks just behind this meeting room. So please queue up to collect your lunch, there will be vegetarian and non-vegetarian food at the back. Thank you very much.
Yeah, and just a reminder, men students over to Ellison Dixon for lunch.